Hello, welcome back for the second video for lesson 9.5. I had lots of examples, so I thought I would break it up into two videos so that you could choose to watch the second one. So here's the second one with some more examples. In a random sample of 80 college graduates, 44 said they would not marry a person based on only love at first sight criteria. For a random sample of 120 high school graduates, 42 said that they would not marry a person based only on love at first sight criteria. At alpha equal to 0.02, would you say that there is a difference in the two proportions? So we are looking at proportions, qualitative data, and it says, is there a difference? So that's going to be a two-tailed, not equal to. So it's two samples. So I'm going to record my college and the people that said they would not marry at love at first sight, and there were 80 in the sample. And then the high school, there were 42 out of the 120. And they just want to know if they're not equal. So my hypothesis is going to be, I'm going to call it P of C is equal to P of H for high school. And we're proposing that they're just not equal. And so our picture is going to be a two-tail down here. And we're comparing this to alpha 0.02 this time. And our test statistic, because it's proportions, is going to be a Z test statistic. And we're going to use the Desmos program for two proportions on this one. So let's just head there now. So there's drop downs in this program, one for group 1 and one for group 2. So group 1, there were 80 in the sample size and 44 said no. In group 2, there were 120 in the sample size and 42 said no. And we are going down and choosing the not equal to. Now in this one, if you click on the extras, that's where they're going to give you your you're going to see some other pieces. If you wanted to see the proportions down here, they'll let you know the proportions of your p hats, and also your test statistic is right here, the 2.798. Well, actually 2.799. So it's pretty far out there, but we're going to go and look at the p-value by clicking on the not equal to drop down, and there's our p-value. It is pretty small, 0.005. So we can go to back to our paper, and we do have a test statistics that's pretty far out there, and our p-value is less than our alpha, so we do reject H0. So there is sufficient evidence to support the claim that they are different. College graduates and high school graduates. Example 5 was another one that I had not yet done with you all. It says in Cleveland, a random sample of 73 male carriers showed that 10 had been bitten by an animal during 1 week. In Philadelphia, in a random sample of 80 male carriers, 16 had received animal bites. Is there a significant difference in the proportions? Okay. We are not going to find the confidence interval. That should just say, is there a significant difference? So we're going to do a hypothesis test here. So we're saying, I'm going to say P of C for Cleveland is equal to P of P for Philadelphia. And they're just asking about a difference. So it's going to be a not equal to again. So we're going to have two-tailed on our picture. And they want us to use alpha at 0.05. And we're going to have a z test statistic. And then in step 5, we'll compare our p-value to our alpha 0.05 to make our decision here. So I'm just going to organize my Cleveland. My sample size was 73 and X was 10. In Philadelphia, my sample size was 80 and X was 16. And this time, let's just write down our p-hats from the program so we can validate that. Now I'm going up here to my group 1. There were 73, 10, 80, 16. I'm going to go down to my extras and just get my p-hat. So my p-hat for Cleveland was 0.14 and Philadelphia was 0.2. And it was another not equal to, so there's my p-value, 0.2999. I'm going to go back down to my extras for a minute and get my, there is my, here's my z test statistic. It's a negative 1.037. So it's definitely not that far from the mean. Wrap this one up here. Our p-value is larger than alpha, so we do not reject H0. So there is not sufficient evidence to support the claim. And our last example for lesson 9.5, example 6 says the percentage of males 18 years and older who have never married is 30.4. For females, the percentage is 23.6. Looking at the records in particularly populous county, a random sample of 250 men showed that 78 had never married and 58 of 200 women had never married. At the 0.05 level, significance is a proportion of men greater than the proportion of women. So men greater than women. Okay, so we have to show that here. So I'm going to say P of M greater than P of W, just so we can keep them straight. And then HA is, oh, that one's equal to, that's our H0. Our HA has to be the inequality. And alpha is 0.05. And then our test statistic we will get from the program. And we will compare our p-value to our alpha. And it's a greater than, so we're only shading on the right for. And we have, let's just write down our men and women, our data up here that we're going to enter. So we have N, they were 250 and X was 78. And then for women, it was 200 and X was 58. Eight, 58. And look at my extras here. My test statistic is small. It's 0.5049, 0.5050 really. And there's my p hat is 0.312, and the other p hat for women is 0.29. They're pretty close. And then they're not equal. This time we are the greater than, so I'm going to draw that drop down, and then my p-value is 0.307. So 0.3068. And let's go ahead and do, okay. So it's greater than alpha, so we do not reject H0. So there is not sufficient evidence to support the claim. Reach out if you have any questions. I'll give example 6 on lesson 9.5.